All right, hello students, welcome to 6.5 Transformations of Functions. In this video we're going to talk about something that we've been mentioning sort of off and on throughout the course, but now we're going to put it into notes and solidify it. So with any sort of function, we can apply a variety of transformations. So transformations changing where the graph is and how it looks. And the most basic transformation are translations. Translations move the graph, but they don't change the size. And we saw these a lot with quadratics. So if we just add a number to the end, we're moving the graph up or down by the amount of c. If the constant is inside parentheses, we're moving the graph left or right and doing the opposite of c. So if it's x minus 2, we would move 2 to the right. X plus 2, we move 2 to the left. Dilations are when we stretch the graph. So this is like our a value of a quadratic. It either made the quadratic narrower or wider because it was stretching it vertically. So parallel to the y-axis is how we're stretching it. And it's a factor of c units. So we're taking all the y values and we're multiplying them by c. Now if I have the c inside parentheses, and c here is just standing for a constant, I again do the opposite. So now I take all my x values and I divide them by c. So instead of multiplying, we divide. We've also seen reflections, especially with quadratics. If I have a negative on the outside, I'm reflecting over the x-axis. If I have a negative inside, I go over the y-axis. So we can think about these in terms of individual points. So here, I'm taking all the y values, and it's really similar to this dilation. I'm taking the y values, I'm multiplying them by -1. Here I'm taking all my x values, and again, it's the same as the c up here. I'm dividing by -1 is what's happening. Of course, dividing by -1. Dividing by -1 is same as multiplying by -1. And that's what flips us over the y-axis. All positive x values become negative. In this case, moving it up or down, I'm taking my y values and I'm adding c. Here I'm taking my x values and I'm subtracting c. So let's think about this in terms of points. If I started with any random point on my graph f of x, a, b, if I applied this translation, I take the y coordinate and I add c. I am leaving the a alone. The x value is not affected. It's only the y value that's affected. So I'm going to stop the video here, but I'm going to fill in the rest of this, and you try and fill it in on your own as well. Think about whether you're affecting a or b and how that's going to look visually. And of course, if you wanted to test it, we could come into Desmos and we could make ourselves a graph. So let me make a new graph here. So if we just made f of x equal to, I don't know, let's say the square root function. And I'm picking the square root function because it's not symmetric. So if we make square root of x. Now, if I look at a new function that's f of x plus c, I can see that as c changes, my graph is moving up and down. And if I put a random point on my graph, so let's put in a point a f of a, and then I could add a slider for a. So now I have a point here. Well, I would also have the corresponding point a g of a, and let's come back up, and instead of calling this one y, we'll call it g of x. So now I can look at what's happening to my specific point. So as my c value changes, the x value for my point is staying the same, but the y value is changing. So when C is 0, they're on top of each other. If C is 1, it's been moved up by 1. So that's a way you could test your ideas for what each of these things is doing. So go ahead, fill this in, go to the document, check your answers, and then ask me if you have any questions.